Hello guys, Outstanding Chem Academy is here again. Alright, we're on the episode of the series of gas laws. Okay, and right about now we need to dive into what is called Dalton's law of partial pressure. Welcome back to my YouTube channel. My name is Adele D. Kazum, your host on this channel. Okay, uh, please do well to keep subscribing to my YouTube channel. Make sure you press the notification button. At the same time, your comment is very important. Thank you for staying tuned. Thank you. Let's quickly dive in together. Right. Now, the first thing, let's look at the definition of Dalton's law of partial pressure. By definition, Dalton's law of partial pressure states that if there is a mixture of gases which do not react chemically, the total pressure exerted by the mixture is equal to the sum of the partial pressure. The individual gases that makes up the mixture. The pressure exerted by these individual gases are called partial pressure. So let's look at it mathematically. Mathematically, we have total pressure, that's total, P total, equals to partial pressure of gas A plus partial pressure of gas B plus partial pressure of gas C. Want to go to partial pressure of the last gas. All right. What you are saying is that when a gas is collected over water in the laboratory, water vapor mix with the collected gases, and the total pressure exerted will be that of the pressure exerted by the gas and water vapor. See what we are saying on the board. Now we can see that we have P total. We give us P gas plus P water vapor. Water vapor. In other words, making my P gas the subject of formula, our P gas equals to P total minus of P water vapor. Okay, let's really look at example. All right, let's look at example one. Example one says, if a gas is collected over water at temperature of 6 degrees C and 765 mmHg, that's the pressure, what is the true pressure of the gas? If the saturated vapor pressure of the water at 6 degrees C is 7 mmHg. So let's look at this formula. P total equals to P gas plus P dry, no, or P water vapor. Water vapor. So we are looking for P gas. So P gas is going to be what? PT minus P water vapor. Since they have the same temperature, look at it. The temperature is at 6 degrees. So the total pressure is 765 mmHg minus the pressure of our saturated vapor pressure, which is going to be 7. So when you do that, you're going to have something like 758 mmHg. Did you get that? That's our P gas. Did you get that? Okay, example 2. Let's look at example 2. A certain mass of hydrogen gas is collected over water at 6 degrees C and 750 and 765 mmHg, occupy a volume of 35. Okay, calculate the dry volume. Calculate the dry volume at SCP. The total vapor pressure of water is 7 mmHg. Okay, and this 7 mmHg, of course, is at what? At 6 degrees C. So let's take note of that. So the first thing to do is to get our pressure of the gas. So we're going to use, remember, our formula is P is equal to Pg plus BWV. So our Pg equals to PT minus PWV. My PT here is going to be 765 minus 7. Look at it, minus 7. So my Pg is going to be 758 mmHg. So the next thing, we are going to be using our formula from general gas equation. P1 V1 over T1 equals to P2 V2 over T2. What I like doing is to get the analysis of all this first. Let's get the analysis so what's our P1? Our P1 is the dry gas, which is going to be 758 mmHg. So our P2, since it has STP, remember I told you at STP, since it's mmHg, is going to be 760 mmHg. All right, our V1 has been given to be 35 cmq, and our V2, of course, is unknown. We are calculating our V2. So now our T1 will be 6 degree plus 273. So if we do that, we have what? 279 K. That's our T1, and our T2 will be 273 K. Remember at STP. So what we just need to do now is to substitute respectively all the values. Okay, respectively all the values. So let's please substitute our P1, which is 758, multiplied by our V1, which is 35, over our T1, which is 279, equals to our P2. Our P2 was 760, and our V2, that's unknown, divided by our T2, which is what? 273K. So let's cross multiply. In our cross multiplication, when you do that, you're going to have something like 758 multiplied by 35 multiplied by 27 divided by 279 multiplied by 760. Okay. Finally, our volume. Let me give you 1 or 2 minutes to calculate our volume. Okay, our volume is going to be 34.16. 34.16. Did you get that? Did you get that? 34.16. Let's go to number 3 quickly. All right, example 3 says 50 cm3 of a gas was collected over water at 10 degrees C. Are you following? And 765 mmHg, coincidentally, another the same pressure. Calculate the volume of gas at STP if the saturated vapor pressure of water at 10 is 5. So let's do the usual thing. We have P gas equals to PT minus what? P.WV. So PT is 765 mmHg minus our P water vapor. You can say it's 5. So our P gas will give us 760 mmHg. So let's do an analysis. The same formula we are using, P1 V1 over T1 equals to P2 V2 over T2. Are you following? Are you following? Are you following? All right. So let's check our analysis. My P1 will be this 760 mmHg. My P2 at STP for mmHg is also 760, coincidentally. All right. My V1 as given is 50. My V2 is my unknown. Stay with me, everybody stay with me. And my T1 is 10 degrees C. We are going to add 273 to convert it to Kelvin. So we have 283 Kelvin. My T2 at STP is going to give me 273 Kelvin. It is standard. That's standard. All right. So let's quickly substitute the value respectively Then we calculate. Now, my V1 we have 760. 760